Hello everyone, I'd love to welcome each and every subscriber of ours to our session today. If you haven't subscribed yet, please do subscribe and extend your love towards our channel. In today's session, we'll be dealing with number series. Number series is a very important topic. When it comes to placement papers, you'll find at least one question based on number series. But when it comes to banking or any other competitive exams, you'll find at least 5 or 6 questions based on number series. So, before beginning with the topic, let me tell you the importance of preparing for this topic. The first and foremost importance is that it will save you a lot of time. Yes, you might be asking me how it saves you time. So, it will not have lengthy questions like in other reasoning topics. Hence, the questions will be of single line, so it will save you a lot of time. Then, you need not have to buy out even a single formula to crack this topic. Yes, so let us begin with number series. I am Kanaka, your aptitude trainer. Till now, I have told you the importance of number series. Now let us see what number series is. Number series, as the name suggests, it's the arrangement of numbers in a particular order. Or it is a series of numbers. It will be arranged in a particular order based on some logic. We as aspirants will have to crack the logic and answer the questions. For people who haven't understood what number series is, let me take up a simple example. So my first example goes like this. The first term of the series would be 2. And then it would be 5, followed by 8, then 11, and then finally 14. So this is nothing but the arrangement of numbers in a particular order based on some logic. So we'll have to crack the logic and answer the questions asked. To solve any question based on number series, I'll teach you simple steps which you need to follow to identify what might the logic be there. So the first step would be compare the first term and then the last term. Take the difference between the two terms. If the difference is very small, first write that down. The difference is small. When you take the first term here, which is 2, and the last term here, which is 14, and you take the difference, it is 12. 12 is not very big, so the difference is small. So I've written it down. Then start comparing the numbers. Are they increasing or are they decreasing in the series? When you see the first term, which is 2, is going on to become 5. And then 8, and then 11, and then 14. So the terms are increasing. So let me write that down as well. So the terms are increasing. So our next final step would be to check if they're increasing gradually or drastically. So here the term 2 is going on to become 5, then 8, and so on. So there is a gradual increase. So for people who don't know what gradual increase is, let us take an example. So if the number is small, then it is becoming big, but not very large, but it is going on to increase gradually. If the number is very small and it starts increasing drastically, so it would be looking somewhat like this. So the first term will be very small, the last term would be very huge, and there will be a drastic increase. So this is what gradual or drastic increase is. In our series here, the increase is gradual. Number 2 is not drastically increasing, it's gradually increasing. So once you've followed these 3 steps, if the term is very small or the difference is small, start taking the difference between the first term and the second term and successive terms, so on. So the first term here is 2, the difference here is 5. The second term is 5. So the difference would be 3. So what about second term and third term? When you take difference between second term and third term, the second term is 5, the third term is 8. So the difference again would be 3. So let us not worry about the sign now. So let us start taking the difference. Again, what about 8 and 11? Again the difference is 3. What about 11 and 14? Again the difference would be 3. Since the series is continuously increasing, which we have noted down here, we'll have to use the sign positive. Because if there is a positive sign, if you add 3 to 2, you get 5. So it is positive. So again, the same thing follows here, here, and here as well. So you've got the logic here. What is the logic? First term goes on to increase by 3 to become the second term. And again, second term goes on to increase by 3 to become the third term. So our logic here is plus 3. There can be various logics involved in a single question. So what are those logics? It can be either addition or subtraction or multiplication and division as well. Not just these, they can also be squares and cubes. So let me teach you how to approach the question when you have different logics. I hope everyone have understood what our three simple steps are and how to follow the steps and get our final answer. Let us take another example, apply the same steps and try to get the answer. So what's the first term here? 99. What's the last term here? 79. Compare 99 and 79. Take the difference. The difference here would be 20. And the difference is not very big. So let me write down for the initial problems and then let me not write down any of these things. So next step, what would you do? You will compare the first term and third term and so on. Check if the numbers are increasing or decreasing. The first term here is 99. It's going on to become 94 and then 89 and so on. So the series here, the numbers in the series are decreasing. So is it a gradual increase or gradual decrease or a drastic decrease? It is a gradual decrease here. So I've noted it down like this. So it's a gradual decrease. So when you know the difference is very small, what do? You start taking the difference. Take the difference between the first term and the second term. What is the difference here? 99 and 94. So the difference here is 5. What about second term and third term? 94 and 89. What's the difference here? The difference here again is 5. What about 89 and 84? Again the difference would be 5. What about 84 and 79? Again the difference is 5. But unlike in the last term, this series is decreasing. Hence whenever there is decrement, we'll have to use negative sign here. So why do we use the negative sign here? Because 99 is decreasing by 5 to become 94. And again 94 is decreasing by 5 to become 89. Hence whenever there is a decrement, we have to use a negative sign. So what if I ask you, what would be the next term here? If my question is like this, what would be the next term after 79 in this series? The next term would be 74. How did I tell you the next term is 74? I did nothing but subtract 79 by 5. So if I subtract 79 by 5, I get my final answer, which is 74. Let us look at our next example here. Let us follow the same steps. So what's our first step? We'll compare the first term and the last term. The difference between 16 and 64 is small. So I'm writing it down. And then the series is going on in incrementation order. So I'll write there is an increment here. And is it a gradual increase or a drastic increase? It's a gradual increase. So I've written that down as well. So let us start solving the problem. Whenever the difference is small, what do? We start taking the difference. But wait, do we need to take the difference over here? Look at the terms. The first term is 16, then 25, 36. What strikes to your mind? If not any other number, at least 25. What strikes to your mind when you see 25? 25 is nothing but 5 square, isn't it? Yes. What about 16? When you see 25 is 5 square, what can 16 be written as? 16 is nothing but 4 square. What about 36? 6 square. So we have already cracked the logic. The successive terms are the squares of successive numbers. So what about 49? I can blindly write it as 7 square. Is it right? Yes. 7 square is 49. So what about this one? 64 is 8 square. What if I ask you what would be my next term? What would be my next term? The next term would be nothing but 9 square. What is 9 square? 81. And 81 will be my final answer. Let us move on to our next example here. This example is similar to the previous one. When we started searching for the square numbers. When we look at these terms, at least when you look at 225, we'll have to identify that 225 is 15 square. So when you identify 225 is 15 square, what would be 196? 196 is less than 225. So since 196 is less than 225, here it should be 14 square or 13 square or 12 square. But how did I directly write it as 14 square? Since I know that 196 is 14 square. And we have repeatedly told you to by heart squares till 25. If not 25, at least till 20. So I know that 256 is 16 square. And what about 169? It is 13 square. And what about 144? It's 12 square. So coming to this problem, whenever you look at the problem, when you see one square term, you will have to identify that and then look for the previous term. If that is also a square term, then the logic would be that the numbers would be squares of successive numbers. So what if I ask you what is my next term here? what would be my next term? Next term would be 17 square. What is 17 square? 17 square is nothing but 289, and that will be my final answer. Let us move on to our next example here. What did we do till now? We took the first term, we took the last term, started comparing the first term and the last term, took the difference between them. The difference between 8 and 10,368 is very huge. So we wrote it down. So after taking the difference, what did we do? We started comparing the successive terms. We started seeing if there is an increment, decrement, or both increment and decrement. So 8 is going on to become 48, and then 288, and then 1728. So there is an increment here. Is the increment gradual or drastic? The increment here, see, 8 is becoming 48, and then suddenly 288, and then 1728. So the increment is drastic over here. So let me note down like this. So whenever my difference is very huge and the increment is drastic, what do I need to do? I need to look for multiplication operation. Whenever the difference was small, we started looking for addition. We took the difference and started looking for addition or subtraction. Whenever the difference is very huge, we need to look for either multiplication or division. What if I multiply with 8, I get 48? I'll have to multiply 8 with 6 to get 48. 8 into 6 is 48. Let me check this logic for the next term as well. What if I multiply 48 with 6? 6 into 40 gives me 240. 6 into 8 gives me 48. 240 plus 48 gives me 288. So my logic is working here as well. So let me check for the next term. What is my fourth term here? It should be multiplied with 6. So what if I multiply 288 with 6? What do I get? 200 into 6 gives me 1200. So 6 into 8 gives 80 gives me 480. 1200 plus 480 gives me 1680. So finally 6 into 8 gives me 48. So 1680 plus 48 gives me 1728. So my logic is working here for 3 consecutive terms. So whenever you get 3 consecutive terms as same logic, the fourth one will also be same logic. You need not check for the complicated terms here. We can say it would be having the same logic when you get 3 same logics. Let us move on to our next example here. What did we do till now? We started comparing the first term and the last term. Took the difference between the first term and the last term. The difference here is 7168 and 7. The difference here is very huge. So let me write that down. The difference is huge. For the second step, we started comparing the terms, successive terms. So 7168 is going on to become 1792, and then 448, and then so on. So there is a decrement here. Is the decrement gradual or drastic? 7000 is going on to become 1792. So there is a drastic decrement. So there is a drastic decrement. So let me write down somewhat like this. So when you start checking, whenever the difference is very huge, what did we do previously? We started looking for multiplication operation. But then the numbers are decreasing in the series. So what do we need to do? We need to check for division operation here. So what if I divide 7168 with, I get 1792. What do we generally do? We divide 7168 with 1792 to get the logic here. But won't that get complicated? Will that be easy? No. So what do we need to do? Whenever the terms here are huge, whenever the terms in the beginning are very huge, we'll start from the ending. We'll go to the ending and start multiplying, because when you go in this order, it is division. So what is reciprocal of division? Reciprocal of division is nothing but multiplication. So let's start multiplying 7 with some number to get 28. What if we multiply with 7, we get 28? If we multiply 7 with 4, I get 28. So the logic here is multiplication by 4. But multiplication is for old good when you come from the end. So what if you go from the beginning? You'll have to divide the first term by 4 to get this term. Let me check that logic once again. Let me divide 112 with 28. Instead of dividing 112 with 28, I'll multiply 4 to 28. So 4 into 20 gives me 80. 4 into 8 gives me 32. 80 plus 32 gives me 112. So yes, my logic is working here. Let me check once more. So what if I multiply 112 with 4? What do I get? 4 into 100 gives me 400. 4 into 10 gives me 40. So 440 plus 4 into 2 is 8. So if I multiply 112 with 4, I get 448. So my logic is right. So whenever I'm coming from the ending, I'll have to multiply the last term with 4 to get the last but one term. Whenever I'm starting from the beginning, I'll have to divide the first term with 4 to get the second term. So my logic here is divided by 4. Let us move on to our next example here. Still now, what did we do? We took the first term, we took the last term, we started taking the difference. What is first term here? 20. What is my last term here? 4.25. But wait, what do we have here? We have a decimal point here. So whenever we have a decimal point there, what do we need to know? We need to know that there must be division operation involved here. So whenever there is a decimal operation, there is division operation involved in the series. So let me check my second term. What is my second term? Second term is 11. What is 11? Where is 11 with respect to 20? 11 is somewhere near to half of 20. What is half of 20? Half of 20 is 10. So 11 is somewhere near to half of 20, which is 10. So what can I write 11 as? 11 can be written as 20 divided by 2 plus 1. So 20 divided by 2 plus 1 is nothing but 11. So let me check this logic for the next term as well. What is 11 divided by 2? 11 divided by 2 is 5. 5 plus 1 is 5.5, sorry. 11 divided by 2 is 5.5. 5.5 plus 1 is 6.5. So what can I write 6.5 as? 6.5 can be written as 11 divided by 2 plus 1. So it's nothing but 6.5. Let me check the same logic further, if it is applying further as well. Let me take 6.5. Let me divide 6.5 with 2. What if I divide 6.5 with 2? What do I get? If I divide 6.5 with 2, I get 3.25. So 3.25, 6.5 divided by 2 plus 1. 6.5 is 3.25 plus 1 is 4.25. So my logic is working here. So what's my logic here? Logic is, to get the second term, I need to divide the first term by 2 and add 1 to it. So the same logic works here as well. Divided by 2 plus 1. Hence my logic here is divided by 2 plus 1. Till now, we have seen how to approach a question whenever you see a question based on number series. Now let us see the questions which were appeared in previous year's examinations. So based on the previous year examinations questions, I have classified the questions asked in the examination into these three types. The first one being missing terms. They would have given a series in which one term would be missing. So we need to crack the logic of the series and find that missing term. And the second one being wrong terms. One of the term in the series will be wrong. We'll have to look at that term. We'll have to find that term by finding the logic. And that term would not be following that logic. And hence the name wrong term. What about the last type? Last type would be double term. What is this double term? There will be two different series involved in one single series. So there will be two different series involved in one single series. So we'll have to find those logic of both the series and then find two missing terms. That is nothing but double terms. Let us look at the problems which have appeared in previous year examples under the concept of missing terms. So what is the first term here? What did we do? What are the steps we followed? We took the first term. We took the last term. Here the last term is missing, hence last but one term. We took the difference between the first term and the last term. The difference here is 18 and 62, so the difference is not very big. So then we started comparing the terms, comparing the successive terms. So the first term here is 18, then 21, and it's going on to become 28. So there's an increment here. Is the increment gradual or drastic? The increment here is gradual. So whenever the difference is small and the increment is gradual, what did we start doing? We took the difference here. What do we get when we take the difference between 18 and 21? The difference between 18 and 21 is 3. Since there is an increment, it's plus 3. So what about 21 and 28? When we take difference between 21 and 28, we get 7. And again there is an increment, hence plus 7. So 21 plus 7 gives me 28. So what would be my next difference here? What if I subtract 41 and 28? What do I get? So 41 minus 28 gives me 13. So what about 41 and 62? 41 plus 1 gives me 42. Plus 20 gives me 62. So my final term here is 21. So when we look at this, we haven't arrived at any logic yet. But we need not stop here. Let's start taking the difference again. Let us consider this as our next series. Let us compare the first term and the last term here. The first term and the last term, the difference is not very big. So we start taking the difference between the first term and the second term. So what is the difference between 3 and 7 here? The difference between 3 and 7 is 4. What about 7 and 13? 13 minus 7 is 6. So since there is an increment, it's plus here, again the plus. So what about difference between 13 and 21? 13 plus 8 gives me 21. So plus 8. When you look at these terms, what can you identify? See, the first difference here is 4. Then it is 6. Then it is 8. It's nothing but successive even numbers. So what must be my next difference here? The next difference here must be plus 10. So which is the even number after 8? It is 10. So my next difference must be 10. So if this difference is plus 10, what would be my next term here? 21 plus 10, which is nothing but 31. If this is 31, what would be my missing term here? Missing term would be 62 plus 31. What if I add to 62? What if I add 31 to 62? What do I get? So if I add 31 to 62, I get 93, which is my final answer. Let us move on to our next example here. So what did we do? What are the steps we followed? We took the first term and we took the last term, compared them. When you compare 38 and 203, the difference is not very big. And then there's a gradual increment. Hence we started taking the difference here. What is the difference between 49 and 38? The difference between 49 and 38 is 11. If I add 11 to 38, I get 49. Since there is an increment, it's positive. So I need to add 11 to my 38. So what about my next term here? What is the difference between the second term and the third term? The difference here is 49 plus 2 gives me 51 plus 20 gives me 71. So I need to add 22 to 49 to get 71. What about my next term here? So next term is 104 and my previous term is 71. So what if I add to 71 I get 104? I need to add 33. 71 plus 3 gives me 74 plus 30 gives me 104. So wait, when you look at 11, 22 and 33, what do you understand? What are these 11, 22 and 33? They are the multiples of 11. Yes, they are the multiples of 11. So what would be my next difference here? Based on this logic, my next difference must be plus 44. So I need to add 44 to 104. What if I add 44 to 104? What do I get? I get 148. So let me check if my answer which I've got is correct. So how can I check that? The difference between the last term and the last but one term must be plus 55 based on this logic. So when I add 55 to 148, I need to get 203. Let me add that. So 148 plus 50 gives me 198. 198 plus 5 gives me 203. Yes, I'm getting the right answer here. So hence the answer which I've got is correct. So let us move on to our next example here. Let us take the first term, which is 177, and the last term, which is 133. Let us take the difference between the two terms. The difference is not very big. So let us start checking if there is an increment or decrement. So here 177, there's an increment to become 178. So next 178 and 170, there's a decrement. So let me write that down. There's a decrement here. So what about my next term? 177 to 197, there is again an increment here. What about my next term here? 197 is going on to become 133. So there is again a decrement here. So whenever there are increment and decrement, but my difference is not very big, let me again take the difference between the first term and my second term. What is the difference between 177 and 178? The difference is 1. Since there is an increment here, it is plus 1. So what about my next term? When I take the difference between 178 and 170, what do I get? I get 8 as my difference. But there is a decrement here. Hence, since there is a decrement here, my logic here must be minus. So I'll have to subtract 8 from 178 to get 170. What about my next term here? Next term, there is an increment. So it is positive sign. So what if I add to 170? I get 197. I need to add 170 plus 7 gives me 177 plus 20 gives me 197. So it is plus 27. So what about my next term here? What's happening here? Again, there's a decrement here, so it's a negative sign. So what if I subtract from 197, I get 133. 197 minus 4 gives me 193. Minus 60 gives me 133. So minus 64 would be my next logic here. So when you look at these terms, plus 1, minus 8, plus 27 and minus 64. What can you understand? Since there is an alternative increase and decrease, next my term should be increasing. So my next logic must have plus sign here. What about the numbers here? 1, 8, 27 and 64. What are they? They're cube numbers, isn't it? 1 can be written as 1 cube. What can be 8 written as? 8 can be written as 2 cube. What about 27? 27 is nothing but 3 cube. And 64 is 4 cube. So what would be my next term here? It should be 5 cube. So what is 5 cube? 5 cube is nothing but 125. So since there is a positive sign here, I need to add 125 to this 133 to get my final answer. So let me do that quickly. 133 plus 100 gives me 233, plus 20 gives me 253, plus 5 gives me 258. So my final answer would be 258. Let us move on to our next type here, which is wrong terms. In this series, there is one wrong term which we need to find out. So which would be the wrong term? Let us apply the same logic here. Let us follow the same steps. Let us take the first term here, which is 18, and the last term here, which is 91. Let us take the difference between them. But wait, what do we have here? We have a decimal point. So whenever there's a decimal point, what did I tell you previously? We need to look for division operation. So what is 10 with respect to 18? Is 10 somewhere near to half of 18 or 1/3 of 18 or 1/4 of 18? Let us check that. What is half of 18? Half of 18 is 9. So what is 10? 10 is somewhere near to half of first term, which is 10 is nothing but 18 divided by 2 plus 1. So let me write that down. 18 into 1 by 2 plus 1 gives me 10. What about the next term? Next term is 11. What is 11 when compared to 10? 11 is somewhere near to 10 itself. So what should I multiply with 10 to get 11? I should multiply 10 with 1 and then add 1 to get 11. So what is my logic here? Nowadays, into 1 by 2 plus 1. Here it is into 1 plus 1. Next one can be into 1.5 plus 1 or 2 plus 1. So let me check for that logic. What is 17.5 when compared to 11? Let me first multiply 11 with 2. So if I multiply 11 with 2, I get 22. 17.5 is not near to 22. So let me take 1.5. What can I write 1.5 as? 11 into 3 by 2. Yes. 1.5 can also be written as 3 by 2. So if I multiply 11 with 3, I get 33. If I divide 33 by 2, I get 16.5. So 16.5 plus 1 gives me 17.5. Yes. So my logic would be into 1 by 2 plus 1, into 1 plus 1, into 3 by 2 plus 1. So what should be my next term here? It should be, what is my previous term? 17.5. So 17.5 into 2 plus 1. What is 17.5 into 2? 17 into 2 is 34. 34.5 into 2 is 1. So 34 plus 1 is 35. 35 plus 1 is 36. So my next term should be 36. So what's my next term here? Next term is 35. So that is the wrong term. It should be 36. So let me verify that. Let me verify if 36 is the right answer. How to do that? Let me take 36 here. Let me take 36 here. And what should I multiply here? I should multiply 36 with 2.5. What is 2.5? It is nothing but 5 by 2. So I have to multiply 36 with 5 by 2 and add 1 to it to get my final answer. So let me check. 36 by 2 is nothing but 18. 18 into 2 is 18 into 5 is 90. 90 plus 1 is 91. Yes, I'm getting the right answer here. So my term should have been 36, but there is 35, which was the wrong term, and we found out that 35 is the wrong term, and that is my final answer. So let us move on to our next type of questions here, which is double terms. How to solve this? As I've already told you, there must be 2 or more series involved in this. So let me check. Let me see which are the numbers which are close to each other. 40 and 39 are close to each other. 44 is also close to them. So let me not do that. Let me skip one term. Let me go to my next term here. What if I go from 40 to 44? What is the difference here? The difference here is 4. To become 44, 40 has to increase or decrease. There's an increment. So it is plus 4. 40 plus 4 gives me 44. What about my next term here? Again, there's an increment of 4. 44 plus 4 is giving me 48. So what about these terms here? So let me check for these terms. 39 and 35, what is the difference here? 39 and 35, the difference is 4. But 39 is reducing here to become 35. So hence, there's a negative sign here. What about my next term? 35 and 31, again there's a decrement of 4. So what's my logic? There are 2 series involved. In one series, there's an increment of 4. And another series, there's a decrement of 4. So what would be my next missing term here? The first missing term of me would be plus 4 to 48. If I add plus 4 to 48, what do I get? 52. And that 52 will be my first missing term. What about my second missing term? Second missing term would be from the second series which is present here. So for second series, what is the logic here? The logic here is minus 4. So I'll have to subtract 4 from 31 to get my next answer. What do I get if I subtract 31 and 4? If I subtract 4 from 31, I get 27. And 27 would be my final answer. So, we have solved just one question based on wrong term and one question based on double term. So, see more content on wrong term and double term. Please do subscribe to our channel, and we will be solving this in our advanced courses.